No one needs to be reminded of the importance of multiplication in our daily lives, but it may be well to think back on the importance of accuracy. Suppose a soldier received ammunition that wouldn't fit his cannon because someone made a mistake in multiplication when the ammunition was made. Or, suppose a worker received only part of his pay because the paymaster couldn't multiply accurately. Usually, the one who makes the mistake never finds it out. Someone else must suffer for it. So multiplication is a responsibility as well as a problem. Most people think they understand the operations in arithmetic, but they have actually only memorized the rules. Here is a simple task. These are Roman numerals. Can you multiply them without using Arabic numerals? It is easy if you understand the principles of arithmetic. If you were able to work that problem, you can skip the rest of the story. We are going to start at the beginning. Before we can work with understanding, we must realize that the numbers themselves are counters, sums, and products. We have only 10 counters: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Other numbers must be made up of their sums and products. Only when we realize that numbers are made up of counters, sums, and products can we really understand what we are doing in simple arithmetic. When we multiply, most of the operation is performed in our heads. We don't multiply 527 times 5 in one chunk. Instead, we multiply 5 times 500, 5 times 20, and 5 times 7, and then add each of the products together. When we understand the principle, we will know why each success of multiplication must be indented, why you first multiply by the units and then by the tens. A multiplication problem can be drawn as an area. Here we see the units, tens, and hundreds being multiplied separately. Starting with the right-hand number of the multiplier, we multiply through, as shown. Whatever number of the multiplier we are using, we place the first number of the product directly below. For accurate results, always place the first number of the product directly below the number in the multiplier which we are using. When there are zeros in the multiplier, the work is easier if we remember to bring down the zero into the product exactly below the zero in the multiplier. In division, the same principles apply. Now this problem in algebra looks much easier, doesn't it? Divide 14,526 by 18. We start at the left of the dividend and take the lowest number that contains 18. Neither the 1 nor the 14 is big enough to contain 18, so we can put zeros above the 1 and 4 if we wish. Zeros at the beginning are usually left out, however, because the answer is just the same without them. We must take the first three figures of the dividend, 145, to get a number large enough to contain the divisor 18. Now we must guess how many times 18 goes into 145. We put the number we've guessed into the quotient, multiply it by 18, and subtract the product. Now we have multiplied the first number of the answer 8 by the divisor 18. We then subtract this product from the first part of the dividend. Remember that division is a quick way to subtract. Then we bring the next number of the dividend down to the right of the remainder. This new number, 12, is then divided by the divisor, 18. Of course, 18 goes into 12 no times, but we must be sure to put the 0 in the answer. The first two zeros make no difference, but this one is important. 0 times the divisor is still 0, and when we subtract, we still have 12 left. Then we bring down the next number of the dividend. Since the remainder is not changed when we multiply the divisor by 0, we usually leave out this step. We just put the 0 in the answer and bring down the next figure from the dividend. Again, we must guess. How many times will 18 go into 126? We put our guess, 7, into the answer and multiply by the divisor. When we subtract the product of 7 times 18 from the remainder, 126, we have nothing left. The problem comes out even. This means that 18 can be subtracted from 14,526 exactly 807 times. It also means that 807 multiplied by 18 is 14,526. The problem we just worked out is called long division. When the divisor is just one number, 9 or less, it is called short division, because all the multiplying and subtracting can be done in our head. Sometimes the quotient is put under the dividend in short division. Remember that division is a quick method of subtracting. 20 divided by 5 equals 4, or 5 is subtracted 4 times from 20. In our first step of this division, we subtracted 18 800 times in one operation. This left us with 126. Then we subtracted it 7 more times. Many times we find, of course, that division problems do not come out even. We still have a remainder after we have used the last number of the dividend. We can handle this remainder in one of two ways. This last remainder, 4, is still to be divided by 16. We can show this as a fraction of the quotient. Here it is, 4/16, or 1/4. Or we can carry on the division into decimal places. We just put the decimal point in the dividend and add as many zeros as we need to the right. But we must be sure to put the decimal point in the answer directly above the point in the dividend. These two methods really give the same answer. We use the one that is best suited to our purpose. Some combination of numbers will never come out even, no matter how far we carry out the division. But we can use this method to get as accurate an answer as we need. If this were tons of gold we were dividing, we might want to carry it out this far. If we were dividing $20 into 13 parts, there would be no reason for getting the answer beyond 2 places. So, if the third place figure is 5 or more, we add 1 to the figure before it and put a minus sign after the number to show that it is really just a little less than $1.54. How far should this workman carry out this division? His job is to divide a steel bar into 7 equal parts. The bar is just 1 meter in length. This quotient is certainly correct enough, but the last 10 figures cannot be used for... The smallest unit on this rule is a millimeter, or 0.001 of a meter. Thus, only 3 decimal places can be used on the ruler, so the division is carried out to 4 places and then rounded off to 3. There is no need for a quotient that is more accurate than we can actually use. Accuracy in multiplication and division is determined by a good check. Multiplication can be checked by division, and division can be checked by multiplication. For an easier check, it is helpful to reverse the multiplicand and the multiplier. This allows us to use different multipliers, and it will usually catch any errors. Another easy check for multiplication is the adding method. Let's try it. Add the figure of the multiplicand. If the sum is a 2-digit number, add the 2 digits until you have a 1-digit number. Do the same thing with the figures in the multiplier. Multiply these 2 single-digit numbers and add the digits to get a single number. This is our check number. It will tell us if our multiplication is correct. Now we add the figures in the final product. We keep on adding till we get a one-digit number. This is our other check number. If our multiplication is correct, the check numbers will be the same. Try this out with a long multiplication problem. It saves checking time. In a division problem, the divisor times the quotient is equal to the dividend. This is a multiplication problem that can be checked by using the adding method. After we get mechanically accurate and fast with multiplication, we can start using shortcuts. Most shortcuts are based on factoring. Any two or more numbers that are multiplied together are factors of the product. Also, any number such as the multiplier can be divided into factors. We will get the same product if we multiply the multiplicand by one factor and then by the other. Sometimes the two multiplications are faster than the one. Any number ending in 0 has 10 as a factor. If it ends in two zeros, 100 is a factor, and so on. So, when we have a multiplier ending in one or more zeros, we can multiply by the first factor. Then we can multiply by the second factor by merely adding the same number of zeros to our first product. In fact, when our multiplier is 10, 100, 1000, and so on, we can perform the entire multiplication by adding the same number of zeros to the multiplicand. Some people find it easier to divide by a small number than to multiply by a large one. Many numbers have factors that make this possible. To multiply by any of these numbers, we can multiply by 100 first, then we can divide by the denominator of the other factor. Decimal points could complicate our problems in multiplication and division. In multiplication involving decimals, we can find the product as if there were no decimals. The right-hand rule takes care of decimal points. The number of figures on the right of the decimals in the product must be the same as the number of figures on the right in the problem. Factoring also provides us with many shortcuts in division. When the divisor ends in 0, the zeros may be removed and the decimal point moved accordingly in the dividend. Sometimes it is easier to do two short divisions instead of one long division. Some divisors have 100 and a fraction as a factor. Then it may be easier to divide by 100 and multiply by the denominator of the fraction. When the divisor has a decimal, it is factored into a whole number and an even decimal. Then the dividend is divided by the decimal factor first. This is done by moving the decimal point to the right as many places as there are zeros in the decimal factor. Multiplication may be indicated in several ways. The usual sign. No sign between parentheses is understood to mean multiply. A dot in the middle means multiply. The third sign is not recommended where decimals are involved because it easily is confused with the decimal point. The product is always the total of one unit for all the other units. Division may also be indicated in several ways. Either 6 divided by 3 equals 2, or 1/3 of 6 equals 2. Let's also make sure that we remember that the number to be divided is called the dividend. The one that does the dividing is called the divisor, and the answer is called the quotient. In a quotient, we use the word per between the units of the dividend and those of the divisor. For example, 20 miles per gallon. When we see the word per, we know that we are looking at a quotient. Remember, there are two things about arithmetic. Number 1, for speed and accuracy, memorize and practice. Number 2, for aid in mathematics, understand the principles. If you can work a problem with numbers, you can work it with letters, symbols, or functions. Now, if you'd like to try that Roman multiplication again, one method of solving it follows. 27 times 14. Then they rewrite the problem and break it down. You've got 4 times 20 equals 80, and 4 times 7 is 28. 10 times 20 is 200, and 10 times 7 is 70. 80 plus 28 is 108. 200 plus 70 is 270. 350 plus 28 equals 378. What they did was apply the principles of arithmetic. Accuracy with the tables and rules of arithmetic, along with an understanding of the operations of mathematics, lead to the new horizons of geometry, trigonometry, calculus, and algebra. The end. Thanks for watching, folks. Please help support the Film Strip Archives. Like, share, and subscribe to our channel. Cheers.